Okay, let's do another test. If you look at this equation, it's not it's not balanced right now. If I count up all the things there are to count, there are hydrogens to count, chlorine atoms, magnesium atoms, carbon atoms, and oxygen atoms. So there's hydrogen, chlorine, magnesium, carbon, and oxygen, all to count. And they need to be counted on both sides, because what you have on this side, called the reactants, the things that are reacting together, have to be equal to the things on this side, called the products. You can't magically destroy any of these atoms, and you can't magically create any of these atoms, so they have to be equal. So let's see if they are. So on this side, there's one hydrogen over there, there's one chlorine, one magnesium, one carbon, and 3 oxygens. On this side, there's 2 hydrogens, so they're not balanced. Where'd that second hydrogen come from? You can't just create it out of thin air. And there's 2 chlorines. That's also a problem. There's just 1 magnesium, 1 carbon, and oxygens. Be careful. Oxygens are often difficult. There's 2 here, but there's 1 there, so there are 3. So if you look at this, some of the atoms are balanced, but some of the atoms are not. So in order to fix this, you are allowed to add what are called coefficients to an equation. And a coefficient is a big number that you put in front of these different molecules. So you might be able to very quickly see what number we could put in front of here. If we put it in front of here, it would balance these out. If we started this whole reaction with 2 molecules of hydrochloric acid, instead of having just 1 hydrogen on this side, we'd start with 2. And instead of just 1 chlorine on this side, we'd start with 2. And because this 2 multiplies through, it means you have 2 of all of this. So now the equation's balanced.